Hi, I'm Siddharth, and I'll be talking regarding our project, that is smart wheelchair using face tracking. So you have two parts of our project. One is face tracking using Android app, and the other is using MATLAB. I'll be going through how our system works with an Android app. What you see on the left of your screen is an actual scene recording of an Android phone. This is how our application looks like. This is where you can scan the Bluetooth that are available and connect it with the device. Open the face detector to see how the application actually runs. So this is how what you see is when you initialize the app. These are the landmarking points that we have provided. This is just for the user to see where exactly the robot or the wheelchair is moving. These are the Euler angles Y and the Z with respect to the face and the camera position. So while we turn left, we have the change in the Euler angles and we get something written on the screen that says that you're moving left. Similarly, when you start moving right, the box tracks and it makes it move right. So this is how basically the code runs. Just for the purpose of the demonstration for the video and for an easy control of the Android application, we have currently disabled the Bluetooth feature. Now I'll be coming to the code. We have used Android Studio, and that's 3.0. That is what you need, and have an updated Java for to run the code. Under the folders that we'll be providing, you'll need to go down to the src and come down to the folder saying Google Face Detector. We have used the Google Vision API for actually implementing the basic outline of a code that helps us in many ways getting the camera functionality running and being easy and being the implementation of algorithm being much more easier when we try to detect our faces compared to probably using a Python or something else on an Android phone. Now, under the Bluetooth folder, you'll basically find all the features and the functions that are being used to call the Bluetooth, scanning the devices, and sending the data to the hardware, etc. So all those things can be found over these two folders. And then device list, as I said, it will check for all the device lists that are available. um, Face detector is basically where all the source code is running. uh, so up here what you'll find is camera source code preview, setting up the camera. These are the basic Android codes that you need to access your camera, start using it. So we're currently using the face camera, setting the height and the width. So all the basic details regarding how to use the camera. Now the face detector and the face tracker part, these are where the basic part of our code runs. The application basically is mounted here. These are the various things, the basic definitions for how thick we want the box to be, their coordinate system, their face detection, how they're using it, and then what kind of colors that we need. Uh, Setting up all those colors and the paint. Um, so update face is basically the function that uses the algorithms that we have used in MATLAB and similar to them in our Android, and the object is called face. So face, and then this is the object to it. uh, Up here is where we are getting the detective face being done, and you can get the x and y coordinates and get the position. So what you say is using the face object we are able to do that. And then this is how we are able to print the final Euler angles out provided by Google. So we started using that. It helps us in being much more precise with respect to our positioning. This is how we are using the landmarking. We have devised these landmarking points, and then depending on the positions that we get here, we are able to get the various points. That is why it's a bit slow while it works, because once you move left and right, it tries to find the points and it's trying to trace it, so it does take a little bit of time. And this is the definition of the bounding box. Now, though we have a very high precision in terms of we can probably go down to like 2 to 3 degrees precision while we are moving, but just for the feasibility of the project and easy definition, what we have done is we divided our y plane into three sectors, which says going straight, left, or right. If required, we can also divide these sectors into more smaller sectors, more definite sectors. Say about if the plane of y-axis our neck movement is from left to the right, imagine it to be 180. We can divide them into like a sector of 10 degree each, so we can have 18 sectors. That way we can have a more precise control of how our end of the device moves. What we have tested is on various z and y plane, the error does happen, but it is in within a range of 2 to 5 degrees. Up here in the face tracker Java, this is where all the functions and how they are being implemented is being used, the camera and everything. So once you are done with this, we can come down to the main activity. This is where finally all the code is being compiled, how the Bluetooth functionality works, what happens when you click certain objects. So as I said, we have currently disabled the Bluetooth part because in general, unless you connect the Bluetooth, you won't be able to do the face tracking. So just to make sure that the app runs on any mobile device for the moment, for the face tracking, we have disabled the Bluetooth part. The splash screen activity is basically the file which controls this part, in which this is the first screen that is called the splash screen, and this is what you'll see. So this is the overall definition of how our project works in the Android space. Thank you.